Hi everyone, good afternoon, and welcome to KubeCon North America 2024. I hope everyone is doing well and having fun and have gone through a lot of presentations till now and gained some valuable insights. So today we are going to talk about messaging queues and how we are using OpenTelemetry for deep insights and observability within messaging queues. Hi, I am Ekansh. I am a software engineer with SigNoz.
Hello everyone, this is Shivanshu. I'm a founding engineer at SigNoz and also a CNCF ambassador. Also, I am a member and contributor to OpenTelemetry project.
Yeah, so just to give a shout out to SigNoz once, SigNoz is an open source unified observability tool to help each and every one of you. Yeah, let's start. So we are going through the talk outline. We are going to talk about what are messaging queues. I am pretty sure that most of you have already used some kind of messaging queues, such as either Kafka or RabbitMQ or Strimzy or something like that. And we are also going to talk about where all we use it, why do we actually use it, what are the common problems that we face while we are using Kafka or RabbitMQ, why do we think messaging queues are complex, and we will deep dive into one of the messaging queues, which is one of my favorites, but not a part of the CNCF landscape, which is Kafka, and what we do not see with the Kafka metrics. Although Kafka exposes a lot of metrics, but we do not have a lot of actual insights from Kafka metrics. So let's start with what are messaging queues and where do we use it. So a general architecture of a messaging queues look like this. We have a producer or multiple producers, and we have consumers or multiple consumers. And in between that, we have a queue. So what is the producer doing here? The producer is doing nothing but sending in messages for the consumer to consume. But right now, But right now, the consumer is probably not ready to consume these messages. So there is a queue which stores all these messages so that once the consumer is ready to process these messages, the consumer can take a message from the queue and process it. Let me give you an example. So let's say you go to an e-commerce site, you do all the payment, and then the messenger just sends in a message to the queue that, yes, this should be out for delivery now. But the consumer is already processing some kind of event due to which it's not able to take in that particular message at that point of time. So that it will wait for some time. The message will stay in the queue, and once the consumer is ready, it will take out the message and process, and the shipment will go away. So why do we use any type of messaging queues? So we have batch processing. We have event streaming. We have ensuring message delivery. So message delivery. So one of the most common use cases for a messaging queue would be ensuring message delivery. There might be zero uptime on the consumer side. There might be some delay, some lag, something going wrong on the consumer side or the producer side. But we want that the message is consumed. The message can either be an OTP, a payment service, or something like that. So messaging queues ensures message delivery. Apart from that, we have like data aggregation, system decoupling, CDC, and data pipelining, and a lot more which messaging queues can help with. So what can actually go wrong? The thing is that each and every one of us has already had an experience with messaging queues, and we know that messaging queues are hard. There might be some problem within the messaging queue, and we might not be able to sort it out. You will not figure it out until you actually just reboot all the systems. So let's talk about it. So there might be some throttling issues. There might be some broker failures. There can be consumer lag, and you might not know about it, and this might lead to back pressures. There is obviously not enough metrics that we are going to talk about. And then there is high latency and throughput issues. Probably some messages are there in DL queues and are never processed, and we do not know why. So I am going to fight messaging queues, but damn, Kafka got hands. It's difficult, it's complex. Yeah, it's all sort of painstaking. Yeah, messaging queues are complex. Yeah, so the thing is, we as developers try to use messaging queues or probably any application in its default configuration. But while fine-tuning and like getting deeper observability can help them scale better, and knowing what to do, when to do, can help things fix faster. But the thing is that we do not know what is wrong with it right now. So let's dive deeper into messaging queues. Coming back to the previous architecture that I have shown with messaging queues, you see a zoom in icon with that. Let's zoom in. So this is Kafka. I am going to talk about the architecture of Kafka. Kafka is nothing but just some kind of producers who are sending n number of messages, probably thousands, hundreds of thousands. Then there are consumers which are consuming these messages, and these can be probably n number as well. And these can be also aggregated by consumer groups, what type of message to be delivered, where is it to be delivered. In between of that, there is a queue where there is a topic or multiple topics which states which type of messages are to be there in that particular topic. The topic has some kind of partitions, and these partitions can have replica and n number of replicas. So yeah, if we go deeper into Kafka, we see that Kafka gets harder and complex, and we see that Kafka emits a lot of metrics such as what's the retry count, what is the request timeout count, and what is the max in-flight request per connection. But this is actually very small details, and we need more. So we can see that any type of queue, be it Kafka or be it any queue, these are complex. Let's go back to the architecture. We are going to talk about another messaging queue as well, and that is RabbitMQ plus Celery. It has a similar type of architecture in place, wherein we have multiple producers which are producing messages. Probably those messages are going into some kind of brokers. Then there are like queues in between, and those messages are then being read by consumers or consumer groups. So what do we don't see with broker metrics? So Kafka does not directly expose producer-side latencies. No one ever knows why there is a lag. Probably there is a lag on the producer side. Probably there is a problem with Kafka itself, or there is some other problem, but we might never know what is the problem. There might be difficulty tracking producer throughputs across different topics and complex correlations that we are here to solve. Yeah. Next is the end-to-end latency of a message. So the end-to-end latency refers to probably when a message is started from a producer, goes into the queue, and is consumed by the consumer. The consumer acknowledges it. So that is missing with Kafka right now, and that is a key thing that we need to track the processing time per message. Yeah, next we go into the consumer group lag correlation with spans. Here, there is no easy correlation. There are probably spans in place, but there is no visibility which partition is causing the lag, and there is limited visibility into consumer group relations with spans. Infrastructure monitoring gaps. So as a DevOps or an SRE, this is probably your most painstaking problem, where you do not know what are the IO patterns, where is the problem, why is Kafka not working, if there is a problem with the partitions, if there is a problem with the networks, is there any correlation between networks or message delivery problems. So I have been very verbose about the problems till now. So let's talk about these things in a very concise manner. I just want to say that there is no correlation between metrics and traces, the traces and logs, and traces and metrics. So what is the answer to that problem? I just want to thank all the contributors and maintainers of OpenTelemetry. So OpenTelemetry is doing a lot in helping this, and I will hand over the whole presentation to Shivanshu now.
Thanks, Ekansh. Yeah, so before we start diving deep into it, how many people are actually using OpenTelemetry for any of the purposes in production? Nice. There are a lot of people. So I think you would be able to correlate with what I'm going to talk about. So let's revisit the problem that Ekansh mentioned, consumer group lag. Let's just talk about what consumer group lag is. The Kafka provides the native ambience from the JMX server, and you can see the consumer group lag for a given topic, partition, and a consumer group. But there are some problems. We would talk about it. Let's see. For a given consumer group A, there are multiple consumers which are reading from a given partition in a given time. And what would happen is, let's say for some reason, one of the consumer in a consumer group is restarting or is slowing down, it would affect the overall consumer group lag for that consumer group. And how would you know which consumer service is creating a problem? So Kafka consumer matrix, the ambience does not provide that correlation with finer details like which producer service, which partition, and which consumers. There's also a problem of noisy neighbor. So for example, if there are multiple producer services writing to a given topic and it goes to a given partition, for example, if the first producer client, it scales up, then there would be a lot of messages coming from that producer, and that would go to that partition, assuming that both the producer client are using the same message key. That would create problem for the other producer clients because the message would be delayed because there would be too much messages produced from some another producer service. So this sort of create a noisy neighbor problem, but a very finer level details are there in the partition. It's creating a partition level noisy neighbor problem. Okay, so how do OpenTelemetry can help us? We can have client-side instrumentation where before going into that, like what does the client-side OpenTelemetry provides us? So it's provide a stable API. So it's stable in the sense that the semantic conventions make it possible that you can build some services on top of it, meaning for every messaging queue, you would have the same attributes under the same attribute name. It provides instrumentation for different languages and frameworks. From Java to Go to C, you would have every application implementing the semantic conventions, and it would give the out-of-the-box instrumentations. Currently, it's not stable yet, but the APIs are stable, and the Java agent is the most mature agent that we have. So how would you be able to collect and correlate spans with matrix? So first of all, we need to have set up something like this. Assuming we are using only OpenTelemetry as the only agent, so we can configure JMX matrix receiver, which would collect all the ambience from the JMX server of Kafka. We can configure our producer and consumer services to emit spans and matrix directly to hotel collector. And we can also configure Kafka matrix receiver, which can collect matrix from Kafka. Let's see how actually it looks like. So on the receiver side, you can configure your Kafka matrix receiver, which is scraping matrix from the broker. This is plain old JMX ambience, which are being scraped from brokers. It is also scraping topics and consumer matrix, as you can see. This is JMX receiver. It's quite new. I'm not sure if you have used it as a receiver. This JMX receiver uses a JMX matrix gatherer, which is basically an ambient receiver, and it is fetching all the ambience from the broker. And you can configure multiple JMX receivers to receive matrix from different brokers. As you can see here, I have defined different endpoints for different brokers. And finally, you can export it to any OTLP compatible backend and configure the pipelines accordingly. So here, in a distributed system, there are like multiple spans, but if you just filter it out, you would see, okay, there are some services which are producer, some services which are consuming it, they are consumer. And to simplify, I just created a simple thing. And if you see, there is a gap between both these spans. This gap is denoting that this is the time where the message was there in Kafka. And if you want to optimize this delay, you would need correlation between these spans with the metrics. So let's see how you can actually do the correlations. So if you take a look at a span, this is a producer span. Here some of the attributes are getting injected from Java client instrumentation. I'm using a Java auto instrumentation agent. And all the messaging dot attributes are coming from that instrumentation. There are multiple other attributes which are present natively in Java agent, which adheres to the semantic convention. And what would you get after the correlating that with metrics? We'll see this in a bit finer details through a demo. So before we take a look at the demo, let's understand what is the complexity in creating and gathering all the metrics from different Kafka brokers. So you could have different agents collecting broker metrics. So for example, here there are 3 brokers, Kafka 1, Kafka broker 2, and Kafka broker 3. What you can do is you can just have a single OpenTelemetry collector configured with a JMX receiver, which is scraping metrics from different brokers. This is a very easy setup, and because you don't need to manage agent on every broker, but sometimes you would want to have a standalone agent which is running on a different node, and it's scraping metrics from the different brokers and forwarding that to OpenTelemetry collector. This is sort of another way in which you can basically configure metrics collection. Another way would be having the agent installed on the broker itself. This is important when you are using, when you don't want to have a single point of failure for the agents. You can have dedicated agents on every broker, and that would forward all the metrics to OpenTelemetry collector. Right now, Prometheus JMX exporter does that very nicely. JMX metrics gatherer from OpenTelemetry, it also does that. So what's missing with the traces? And what's missing with the metrics? These are the metrics that Kafka provides me. For example, consumer group lag. You can see it shows consumer group, partition, and topic. But we'll see in the demo how we can dive deeper into it if we do the correlations with the attributes. Let's take a look at the demo. So let me show what is the setup. So this is the setup where every producer is sending telemetry to OpenTelemetry collector receiver, and it's also scraping the metrics. So it would be easier if I just show the collector config. It's configured to scrape metrics using Kafka metrics receiver and JMX metrics receiver. And also it's also receiving metrics and traces from producer and consumers through this receiver endpoint. And let's see. And if you do that, you would see all the attributes coming in your spans. So these spans, you can basically use these attributes to basically do the correlation. I would show that via an SQL first. For example, this is my consumer group lag matrix, which contains 3 attributes: group, partition, and topic. And this is a span which contains the client ID, service instance ID, and service name. So what I want is, for a given time, all the consumers that are receiving from that partition, I want network fetch latency for that particular consumer service in that partition only. I can use these attributes to do the correlation, because you can see that the partition is not there in the consumer fetch latency. So if I go ahead and run an SQL where I have defined the kind, consumer group, and partition ID, so it would give me the client ID, service instance ID, and service name, and then I can use that to get the corresponding metrics, for example, network fetch latency. If you implement a backend which can do all this correlation, you can do pretty amazing things. So today, you can basically collect all these metrics from Kafka natively. But as I mentioned, there are not much correlations. But if you do the correlations right, you can, so for example, there's a consumer group lag, and I see there's a spike for a given, for this consumer group 1, topic 1, and partition 2. I want to see why it's happening. I can just click here and would show me all the, once again. Okay, weird. Let me just refresh that. Let's try that again. What I'm trying to show is how you can do the correlations and get the metrics for a given time. Okay, this is getting tricky. Let me try something else. So for example, one of the thing that we mentioned is for a given producer and consumer service, how can I see how many messages are there in that Kafka? So for example, I want to see for a given 10 milliseconds, this is like the time interval that I'm setting. Okay, show me all the messages which are there in the Kafka for more than 10 milliseconds. So total spans are there 43K, but out of which 2.3K spans were there in Kafka for more than 10 milliseconds. And I can go and see all the trace IDs for that corresponding interval. And this is one of the correlation that you can do. You can also do this consumer group thing, but let me just see what's broken here. Let's try some other spike. Okay, this worked. So if I click here, I can get the for that particular consumer group lag. This is consumer group 1, topic 1, and partition 2. The consumer service involved in that, in increasing that consumer lag, is consumer service 1. And both these producers are writing to that particular consumer, so that particular topic and partition. And this is the corresponding network fetch latency. So as I mentioned in the SQL, you can do the correlation and get the partition level metrics for a given span. So this is happening at consumer group 1, topic 1, and partition 2. And also you can go to the corresponding client metrics if there are any. So for example, all the metrics corresponding to that producer, you can take a look at that. And this is all powered by semantic conventions and correlation on top of it. So, okay, let's get back to slides. You can try it out. All of the code is open source. You can make the correlations, see if it solves your problem of doing messaging queues observability. If you are an end user of OpenTelemetry, or if you are interested in contributing to OpenTelemetry, we encourage you to join our SIGs. There is OTel Messaging Semantic Conventions, where we discuss about how to standardize OTel semantic conventions. And also you can contribute via creating issues or contributing via making some changes in our client SDKs, for example, Java and other languages. So that's it for today's talk. Thanks for joining in.
Yeah. We would also like to mention that we are launching this feature of correlations of traces, metrics, and logs on messaging queues with SigNoz today at KubeCon 24. So you can check out SigNoz as well. Apart from that, if you have any questions, please do let us know.